Good morning. This is our first lesson, and that's how we will work from now on, unless we will be suggested by the board what to do otherwise. In this first lesson, introduction to how energy can be gained or lost, and the only way to gain or lose the energy is to do the work. As an example, if Angie is about to score the goal, she needs to kick ball. That way, she applying the force and making the ball move over a certain distance. She does the work on the ball, let's say 100 joules. Because of her work, what the ball will do is gain those 100 joules of work and obtain that much of energy, also 100 joules. So that way, please understand the most important part is in order for an object to gain energy, let's say move faster, what must always be done? The work. And that is the most important concept I need you to understand in this lesson and the following. Because the work will supply the extra energy at the same time, in some instances, for example, with the force of a friction, some other opposite things will happen. Instead of adding energy, the energy will be taken away. For example, I'm referring right now to the word negative work. For example, as you know, if the object is moving to the right and experiencing a significant force of a friction between the tires and the road, it means that due to the force of a friction, the speed of the object is not going to be increased, but otherwise will decrease. So if the same exact example with Angie and 100 joules of work, if there was significant friction, it means that 100 joules of work is not going to be fully transferred to the object. So it will be much less depending on the amount of friction. So the two forms of mechanical energy you and I will look into are going to be kinetic and potential. We will discuss the increases, decreases of energy, why they're happening more in detail later. However, today let's concentrate just on the energy of the moving objects. Any moving object, this even adorable corgis, as you can see them there. Hello. As you can see, they have mass and they have speed. The greater their mass, as you understand, the more destructive force on the little toddler that they can have will more likely knock him or her over. So because of that, then we will treat kinetic energy as the energy, again, as you can see here, of the moving objects. The more mass, the more energy, and as you correctly suspect, a bowling ball versus the baseball, you know that the baseball will have greater speed. Thus, it might have more kinetic energy, even though the mass will be smaller. Kinetic energy will depend on two variables, mass and velocity. It doesn't matter whether the object is moving horizontally or vertically. Any moving object in any direction, it will have kinetic energy, will possess kinetic energy because work had been done to make that object move. We will be calculating kinetic energy by the following formula, which you can find on the bottom of the page in the reference tables, on the 6th page of the reference tables. As you recall, we are almost at the end of mechanics, sadly. The units for work are going to be the same exact as the units for energy. So kinetic energy will be measured in joules. So kinetic energy will be measured in joules. But at the same time, you remember that mass is measured in kilograms and the speed is measured in meters per second. So please see by which means I am getting here meters squared, right? Don't forget, it's a v squared, and I'm getting seconds squared, all right? Has nothing to do with the area. It's only just algebraic multiplication of symbols of the same with the same symbols. using the properties of multiplication with the powers. So here, let's go right to the first problem. And any object moving again will have a mass, will have the speed. To find kinetic energy, what are we going to do? We will need to look at the mass. The greater the mass, the greater the kinetic energy. The greater the speed, the greater the kinetic energy. So here we have the mass, and here we have the speed. So if you want, I will change the color if you cannot see those yellow ones. So here we have the speed. How to find the kinetic energy of the toy car? I'm reminding you, work has to be done to transfer that kinetic energy. Who needs to do that work? You. Pushing the car, pressing on the car, letting it move, either horizontal or vertical. Again, doesn't matter. You still transfer energy. So to find kinetic energy, recall what we just said. Kinetic energy is proportional to the mass and velocity squared. And velocity squared. I will write here a little bit better. I'm learning how to use the screen and I'm writing with my hand, so please be patient. So again, you have the mass, you have the speed, you know what to do very easily. Get your calculators ready. Let's take a look at how it goes. 1/2 5 kilograms times 2 meters second. Only the speed is going to be to the second power. Don't forget, only the speed. So, do you have the time to calculate? What will your answer be? Of course, it's going to be in joules. Let's check. Did you do that right? Did you remember to only square the speed? You did? Excellent. Hard for me to see what you did, but I'm hoping you got this answer. Don't forget again, this answer will be equal to the work being done by, let's say, a person. In addition to that, in addition to this simple calculation, my next slide is going to discuss also the units. You know, again, if you look at the sample worksheet attached to this topic, you'll see that there are questions that require you to know the units. So let's take a look again at what units will work up here. So in here, which units and quantities are correctly paired? Which means which units and quantities are correctly representing each other. All right, since velocity is displacement in a certain time, so therefore it's impossible for that to be, time cannot be to the second power, so therefore this is not the correct answer. Momentum, we hadn't done yet, we're getting there, that will be our last topic. But let's take a look at the energy. It says kilogram meter squared divided by second squared. Okay, so I wonder why this question sits right up here as we were just beginning with the notes. Let's see, kilogram is the unit for mass, all right? Meters squared over second squared. Okay, let's take them together. Meters per second. You know what meters per second are measuring? They're measuring the speed, right? Speed, velocity. So, but you know what the symbol for speed is? It's V. Okay, I wonder why, again, this question sits in here. Isn't that because we just had established that kinetic energy is proportional to the mass and the speed of the object. So your formula for kinetic energy, energy of any moving objects is 1/2 mv squared. Looking at that formula, please understand why choice 3 is the choice you and I were looking into, and this is why that question sits right up here in our topic. The next point I want to address with you is going to be since the class heavily relies on algebra, of course, to continue helping you with your algebra skills, the next question is going to be the graphical representation. Let's see again. In order for you to correctly interpret, to match the shapes with the quantities, you have to keep in mind that kinetic energy will still be expressed as proportion to the mass and proportional to the exponential form of the speed. Don't forget, exponential form of the speed or velocity. Let's see what we have in the first part. Okay, if mass increases, let's say you start with 1 kilogram, you have one form of kinetic energy, keeping speed constant. Then you start